Hello everyone and welcome to Codechef. My name is Anubhav Gupta and I am a grade 12 student at Delhi Public School, Bokaro. The problem which we will be doing today is free ticket which appeared in the Indian National Olympiad of Informatics 2014. The hardness level for the problem is easy and the prerequisites for this question is graph theory. We'll also learn about the Floyd-Warshall algorithm in this problem, which will help us to find the shortest path between any two nodes in a graph. So let us start with the problem. So the problem states that Nikhil Slogan has won the contest conducted by Drongo Airlines and he is entitled to a free ticket between any two destinations served by the airline. All cities served by the Drongo Airlines can be reached from each other by some sequence of connecting flight. Nikhil is allowed to take as many connecting flights as needed, but he must take the cheapest route between his chosen destinations. So this paragraph means that the graph is a connected graph. Now we move on. Each direct flight between two cities has a fixed price. All pairs of cities connected by direct flights have flights in both directions and the price is same in either direction. So what does this means is that the connected graph is bidirectional as well. And the price for a sequence of connecting flights is the sum of the prices of the direct flights along the route. So what does this mean? For example, if we want to go from 2 to 3 along 4, then the price of the total price of the flights would be 15 plus 7, that is 22. Okay. So for now Nikhil has information about the cost of each flight. Like from example from 1 to 2, the cost of flight is 10. He would like to maximize the value of his price, so he would like to choose a pair of cities on the network for which the cost of the cheapest route is as high as possible. So what does this mean is that he has to find the shortest path between all the destinations, all the pairs of destination, and then find the maximum among themselves. So now let us start the explanation. So the explanation is we need to find the shortest path, that is the shortest weight between all the pairs of cities, and then print the one with the maximum shortest distance. So what we can do is for finding shortest distance, we know an algorithm known as Dijkstra's algorithm, which whose time complexity is O of V plus E log E. So we can use Dijkstra's algorithm as well. But now there are a few cons with Dijkstra algorithm. So first one being the code for Dijkstra's is very long and very hard to implement as well. So, and in context, we don't want to write such lengthy code. And also, again, the time complexity for each node is O of V plus E log E, and for each, and the total time complexity would be approximately O of V E log E, considering a dense graph. And now let us see at the constraints of the program. The constraints is that the number of vertex, that is 230, and the number of edges, it is 23,000. So let us consider the number of vertices at 10 to the power 2 and the number of edges at 10 to the power 5. Then the total time taken would be around 10 to the power 7 steps, which is very much under the which is very close to the time limit, which is 3 seconds. So in some cases, the program may not even run. Now let us move on to the second option. The second option is Floyd-Warshall's algorithm. Now why should we use Floyd-Warshall's algorithm? The Floyd-Warshall's algorithm should be used because it has only three nested loops and it is also very easy to write. And the best part is that its time complexity. The time complexity of Floyd-Warshall's algorithm is O of V cube, where V is the number of vertices. So let's see here. The number of vertices is 230 here. So let us consider this as 10 to the power 2. Then O of V cubes means O of 10 to the power 6, which is very well under the time complexity of 3 seconds. And so the problem will run without any problems. So now let us see what is Floyd-Warshall's algorithm. So as we know that Dijkstra is a single source shortest path algorithm, which means that it finds the shortest path between one source node and to all the nodes. But on the other hand, Floyd-Warshall finds the shortest path of each pair of nodes in a graph. And then the Floyd-Warshall algorithm is an example of dynamic programming problem. It breaks the problem down into smaller subproblems and then combines the answer to those subproblems to solve the big initial problem. So we will see how this is referred to a dynamic programming problem. So for example, let us take any between any two nodes I and j. So let us use k is an integer where we'll be using only the first k vertices. So the shortest path using only the first k vertices. For example, let us take k is equals to 1 to n. Now in this graph, what happens when k is equals to 0? Then it means that we have to find the shortest path only using no extra vertices. So the shortest path between 2 to 3 would be 10. Now let us add one more node, that is k is equals to 1. Then the shortest path would be, we can also use the node 1 as well. Then the shortest path would be from 2 to 1 and then from 1 to 3. That is 3 plus 5 equals to 8. Now let us see another example. Now the distance from 2 to 3 is 2. And then when k is equals to 0, when k is equals to 1, the shortest path will actually also be 2 to 3, that is 2. Because when we move from 2 to 1, then the distance is 3, and then from 1 to 3, the distance is 5, and the total distance would be 8, which is more than the direct flight between them. So now let us write the general equation which we formed using these examples. So case 1 would be when the shortest path does not change with the addition of any node. The first case is the shortest path does not change with the addition of a new node. Then the shortest path, let's for example take the shortest path between I and j will eventually be the shortest path between I and j, which is the previous without using the a new node. And the case 2 would be the shortest path does change with the addition of a new node, as we can see here. When we add the node 1, when k is equals to 1, then the shortest path does change. So what would be the shortest path now? The shortest path now from I to j would be shortest path from I to n plus 1, which is basically when we add another node, and plus the shortest path from n plus 1 to j. So here we have a basic general equation which would be used for our DP problem. So here we arrived at Sublime Text. Here I have my basic template, and so let us start with the problem. So the problem says that there are, in the first line there are two integers c and f, where c is the number of cities on the network, which is basically the number of nodes, and f is the number of pairs of cities connected by direct flight, that is the number of flights. So that is the basically the edges. And from line 2 to f plus 1, each line describes one direct flight between a pair of cities and consists of three integers x, y, and p, where x and y are two cities, that is basically the two nodes which are connected, and p is the price, which is basically the weight between x and y. So let us write the code for this. So we will take two integers c and k, where c refers to the nodes, that is cities, and k refers to the cost of the flights, where k refers to the number of edges. So c in ck, we'll take the input, and then we'll make an adjacency matrix of c plus 1 and c plus 1. Now we will mind that we are using c plus 1 because we will be using 1 based indexing, which would make our work a lot much more easier. So now let us initiate every integer to infinite. Int is to c, from 1 to c, I plus plus for int j equals to 1, then j is equal to c plus plus. Then graph of ij would be infinite, and here I have defined infinite as 1 to the power 10 to the power 18 plus 10, which means that there is no path between the two edges. Now let's take the input. So while k minus minus, there would be three variables. The first one is x, which is the, and y, which are the nodes, and the third one would be the weight between them, that is basically the price between the flights. Then we will take the input c in x, y, weight, and then let us add this to the adjacency matrix. Graph of x of y is equals to weight, and graph of y and x is equals to weight. We can also do one more addition here, that when I equals to j, then the graph of ij will become 0, because the cost between two same nodes is always 0. So we'll write if graph of ij, if, or basically we can write if I is equals to j, then graph of ij is equals to 0. So here we have the normal basic input and output, input code. Now let us apply Floyd-Warshall algorithm to this. So we'll be using three nested loops. So first, for int I is equals to 1, I is smaller than equal to k, I plus plus, which would basically be k is smaller than equal to c, and k plus plus, which is basically the number of levels as of how many nodes we will be using for the shortest path. The second and the third nested loops will be for the graph. So int I is equals to 1, I is smaller than equals to c, I plus plus, and for int j equals to 1, int j is smaller than equals to c, and j plus plus. So basically here k refers to the number of nodes we can use to move to the shortest path, and I and j refers to the graph here, between the nodes of the graph here. The shortest path would be graph from I to j would be, as we discussed in the whiteboard here, there were two cases: the shortest path ij and shortest path of I to n plus 1 plus shortest path of n plus 1 to j. So we need to find the minimum path. So we have to find the minimum of both of them. So let us write the minimum is equals to minimum graph of ij and graph of I till k. So we will be including the kth vertex, and from graph of k to j. Now what happens if the if graph of I to k or graph of k to j is infinite? That means there is no path between them. So if this case occurs, if graph of I to k is equals to infinite, or graph k to j is equals to infinite, we will basically continue. Okay, so now it is filled with all the shortest path between all the pair of nodes. So let us now try to print this. For int I equals to 1, I is smaller than equal to n. For int j is equals to 1. So here we will print the graph. So now let's take the input and let's wait for the output. So here it would be C actually, because C is the number of nodes. And see here, we have all the shortest path between any two pair of nodes. The shortest path between 1 and 1 is 0, between 1 and 2 is 10, 1 and 3 is 12, and 1 and 4 is 19. So now what we have to do is, we need to find the maximum out of them. So what we will do, we'll make changes in this code only. We'll initiate a variable mx, int mx is equals to 0, because always the distance will always be positive as it is given in the problem. So now let's mx is equals to maximum of mx comma graph of ij, and so now we have the answer, which, and here the answer would be 19, which is the maximum. Now let us try to print mx endl, and now let us build this program. And as we can see, the output is 19, which matches our sample output. So now let us submit this problem. And now let us click on submit.